Okay, so my whining about imperial units aside, let's try to do 6.1, number 13. Um, I leave these in here not because I leave these in here mostly, I think, because I want you guys to know to be scared of imperial units and try to convince everyone you meet to convert to metric. Just, it's better. Just convert to metric. Everybody.
I work exclusively in gallons and pounds. BTUs.
Yeah, and this is what in here because some engineers do end up working exclusively in imperial units, which is awful.
Terrible. That's just how the American dairy industry is. All of our international folks are always talking in Celsius, and we always talk in Fahrenheit. It throws us off. 30 degrees is very different between Fahrenheit and Celsius.
It's why you can bounce a $2.5 million mission off the atmosphere of Mars.
Terrible.
You guys know that, right? This happened years and years ago. It was basically a failure, and it wasn't quite as failure as it wasn't quite as simple as failure to convert. It was something just a little bit harder than that, but it amounted to failure to convert. All right, so I have a 2-pound weight that stretches a spring 6 inches in equilibrium. So I'm going to be better about this. So that's going to tell me about the spring constant. And then we have an external force of sine of 8t pounds is applied to the weight, which is released from rest 2 inches below equilibrium. Find displacement for t bigger than 0. Okay, so there's a bunch of stuff going on here. First things first, I should probably figure out about that spring constant, right? Mm-hmm. Well, maybe first things first, I should write down my governing equation. So my governing equation, I think, is my double prime plus ky equals f external. Yes? Maybe? Okay, so I'm pretty sure they told me that the external force should be sine 8t. Okay, from previous experience, I believe that I can calculate the spring constant.
There's also another way you could do it, if you don't mind.
Sure.
It's a little faster.
Go for it.
Okay, yeah, because k over m is equivalent to g over the displacement from natural equilibrium, or the 6 inches.
Okay, so you're saying I can replace k over m with what, 6? No, sorry.
The 380 something.
384 is, I think, what we used last time, divided by 6?
Yeah.
So 384 is gravity due to inches? No, the gravity given in inch seconds squared. Inches per second squared. What an icky unit. All right, so we converted everything to inches. All right. Okay, so I have y double prime plus 384 over 6y is equal to sine of 8t over m. I feel weird about dividing by m on the other side.
Oh, yeah, I didn't even realize that.
You guys with me on that? That feels real weird.
Yeah.
This is part of why I don't like the standard system.
Okay, I see. So that I made the mistake there. I didn't realize that, yeah, that only works with homogeneous equations because you have 0 on the other side.
Yeah, I think that's going to be most of my issue.
Yeah.
But I think I could still use this. So I think if I kind of think about this, this is K is 384 over 6M. Right, so I think if I put an M here and an M here, I'm kind of back to where my brain works for a hot minute.
You could also find the weight using the 2 pounds or the mass.
Yeah, so I could find the mass using the 2 pounds, and this is again where my like trepidation about imperial comes in, right? So 2 pounds is what in mass?
Well, it would be something in newtons times, or no, divided by g. I don't know what exactly that is.
Let's see. So 2 pounds is a force, right?
Yeah.
Okay, so it's a mass times an acceleration.
Yeah, that's what I was getting at.
And so the acceleration here is that 384.
Oh.
So I think my mass in this situation is 2 over 384.
I didn't even think about it like that.
Like I said, I'm not actually good at physics, but the reason I can usually solve physics problems given an appropriate amount of time is that you just remember that everything is mass times acceleration.
I don't know if pounds is in inches per second squared though.
Oh, yeah, it's possible that I need a conversion factor here.
Yeah, that's why I was thinking you could convert to newtons and then
Yeah, let's
9.8.
see. So this is in pounds per inch seconds squared. Well, that's fine. My units on mass are just shitty.
Yeah.
I think that I'll be okay, but let's chase it down later.
Yeah. Let's just keep going with what we have.
Well, so this is kind of the horrible thing about the imperial system is that the units are pretty arbitrary. So the mass units that I've got here are not probably standard mass units, but there's still some mass unit that has these. I might need a conversion factor to get to kilograms or whatever, right?
Mm-hmm.
What's the mass unit in the imperial system? Is slugs or some stupid thing?
Oh yeah.
So yeah, these probably are not slugs because my guess is they're twelfths of slugs or something. But fuck it. All right, so I think I'm going to put my weird ass number in. So I have 2 over 384 plus 384 over 6 times. Oh, whoops. What did I lose?
Oh, why?
Y double prime.
Y double prime. Those are important. You're going to want to keep those things kicking around.
Also, this is just a me thing. Can we simplify 384 to 64?
Can we simplify what? Oh, this guy?
Can we just stop hauling around that fraction?
I'm going to cancel it right now. Let's see. This is supposed to equal sine of 8t.
Mm-hmm.
Let's see. So what's 384 over 2? 150 plus 42 is 192. Y double prime. 1 over 192 y double prime plus 1 over 3 y prime. Y is sine of 8t.
Okay.
Okay. Now what?
Now, can we solve for our homogeneous version?
Yeah, now we should be able to solve the homogeneous one. So I should be taking my homogeneous equation over here. So I have YH double prime plus okay, 1 over 192 YH double prime plus 1 over 3 YH is 0. Multiply through by 192. So YH double prime plus 192 is divisible by 3. It is 64. Good work, Jordan. I knew that was going to come in handy.
Oh, wait.
Plus,
That's what I had.
good.
Like when I divided by m.
Yeah, because you're just other side is.
Oh,
No.
yeah, I just had to do it to the other side too. That was my issue.
Yeah, so I didn't multiply through with the other side because I'm dealing with a homogeneous version right now.
Okay, well, I'm just going to keep everything I had then.
I think you should. Yeah, essentially, I just substituted a number in for m, right? I think it should be okay. All right, so you got to here. I need to solve this. So what do I get? YH is C1 cosine plus C2 sine. What do you get for your R's here? I'm going to move that to the other side, right? So, sorry. Am I skipping too many steps? I have this problem with Zoom here where I can't tell whether you guys are bored or lost.
I'm good with the number of steps he skipped.
Okay. Jordan, are you with us?
You know, I'm not even past like week 4 homework, so no.
Okay, so here's what I'm doing. I'm guessing that the homogeneous solution is e to the RT. Then I'm going to plug in, I'm going to differentiate that a couple times. I'm going to plug it in. I'm going to get to r squared e to the RT plus 64 e to the RT is 0. I'm going to notice that I can divide by e to the RT. I'm going to get r is plus or minus 8i out of that. If I cram that in the quadratic formula or subtract and square root, whatever. Then I'm going to use, so this is Euler's identity. And so I'm going to get that my YH is like cosine of 8t or sine of 8t. And then I'm just going to stick those together with some constants. This is coming out of the section 5.2 kind of ideas. Okay, so this is my homogeneous solution. That's the kind of bouncy part of this, right? That's the kind of spring going on. Then where's my external force at? So that's a non-homogeneous bit, right? Okay, so I found a homogeneous piece, and now I'm looking at this thing and I'm seeing, okay, I'm going to run the method of undetermined coefficients on this thing, which is really, Jordan, if you haven't gotten through that section yet, this really just amounts to an educated guess, right? So I'm looking at that right-hand side, and I'm thinking, all right, on the left, I'm differentiating, multiplying by constants, and adding together, right? So if you look at the thing on the right, if I take a sine, differentiate it a couple times, and add it back together to itself, I'm going to continue to have some kind of sines, right? Maybe cosines? Could I get cosines in this case?
Depends on how many times you differentiate it.
Exactly. So I'm going to just go with guessing cosines, even though I might not need them. Does that make sense? Okay, so I'm going to make my y particular guess up right now. And I'm going to guess that it looks like a sine of 8t plus b cosine of 8t. And you guys will notice that my handwriting looks real screwy here because I'm leaving a little space. Why am I leaving a little space?
Because both of those are already solutions.
Yeah, I know what's going to happen if I plug that crap in. It's all going to zero out. Why is it all going to zero out? Well, because that is exactly my homogeneous solution, right? You guys see that those match perfectly? So I know what's going to happen if I differentiate these things and plug them in. They're all going to disappear. Okay, so I need them to not disappear, right? So what's the trick to make things persist through a derivative or two?
Add a t.
Yeah, slap a copy of your variable on it. So I'm going to slap a t here and here. And then this is the part that's probably going to take a little bit, which is that I need to differentiate this thing a couple times. So yp prime is going to be, let's see, so derivative of the first is a times the second is sine of at plus the first times the derivative of the second is going to give me 8at sine 8t. Be with me on that? Oops, what did I screw up there? I should have been differentiating sine of 8t, right? So I got the 8 from the chain rule. What's the derivative of sine?
Cosine.
Yeah, I got so caught up in doing the chain rule and the product rule that I forgot to actually differentiate the thing.
I had that so many times throughout with specifically for the second derivative. I kept forgetting to multiply by 8.
Yeah, you're gonna either when you're doing 3 things in your head, you're gonna lose one of them. It's gonna happen. So you just got to be really, really careful. All right, so here I need bt cosine 8t's derivative. So that's going to be b cosine of 8t. So that's just that first piece. And then I'm going to have plus this 8bt sine 8t. And what else do I need in there?
Minus.
That should be minus that. Okay, and then this is where things really start to hit the fan, because I need yp double prime. Okay, so real slow, real steady. I'm going to do these one at a time. Green thing is 8a cosine 8t. Buddy with me on that? Okay, blue thing. I'm just biting these off the easy ones first, right? So blue thing is going to give me 8b sine 8t. And I lost a minus sign there. That's going to be minus 8b sine 8t. Good with that? Okay. Red things next. So I need the first derivative of the first thing is 8a times the second is cosine 8t. And then I'm going to have plus, and then I need this 8at times, and then I need the derivative of this cosine, which is going to be minus 8 sine 8t. Did I get that right? I think I got that. So I got the derivative of the first times the second plus the first times the derivative of the second.
Yeah.
And then black, we do minus all of. And then let's see, I got the derivative of the first is going to be 8b sine of 8t. And then my second thing is going to be the first times the derivative of the second, which is going to be an 8 cosine 8t. Good with this? Okay, now I need to plug all this stuff in, right? So what am I plugging it into? I'm plugging it into this equation up here, right? So this and this need to both go in there. Okay, let's see. Another color I haven't used yet. All right, so I need 1 over 192 times, and then I need all of this thing. Let's see, so all told that is an, oh God, this is awful. 8a cosine 8t. Oh wait, I have more of those. These guys, those guys are the same thing? Okay. Oh, and these guys are the same thing. Okay, good. So I can simplify a little bit. I'll make my life just a tiny bit easier. Okay, so that's going to be this thing and this thing are 16a cosine 8t. Then I have this one and this one are minus 16b sine of 8t. And then we have this guy and this guy. So this guy, which are going to be a, oops, that one got underlined. Let's see. So this thing is going to be a, they're both going to be minus. You guys see that? So they're minus, this first one is 64 t sine 8t. And this second one is minus 64 bt cosine 8t.
We lost an A on the first one.
I did. 64 AT. Okay. Thank you. That's crucial because that's crucial because everything here is crucial, right? All right, and then I have plus, and I think I have 1 over 3. And here I need my y particular, which was this guy. So I got an AT sine 8t plus BT cosine 8t. And then this is all supposed to equal sine of 8t. Woo! Okay, and this is where things get real. Because now I get to get slap happy crossing stuff out. So what's going to disappear here? What's 64 divided by 192?
Like 1/3.
Yeah, it's 1/3.
Okay.
This guy cancels against this guy, and this guy cancels against that guy. And if you didn't see all the t sine and t cosines drop out, you did something wrong. Go find those suckers. They're going to cancel out because they were the homogeneous solutions. Like, that's why they're canceling right now, is because that solved the homogeneous version, so all of those are going to disappear. It's the leftovers, the things that I designed this to kick, that are going to be helpful for me. And right here, right now, I think I have two equations, essentially. From this guy, actually, let me stop drawing arrows for a second. From the cosine part of this, I have 16 over 192 a cosine 8t, right? That's this piece. How many cosines you got on the right-hand side? Right-hand side, I got sine of 8t. How many cosines are in there? 0. Okay, let's look at the sines. So on the sine side of things, I have minus 16 over 192 is supposed to times sine of 8t is supposed to equal sine of 8t over here.
And a
Your
B.
B, yeah.
And whoops, thank you. So minus 16b over 192 is supposed to equal sine of 18. So I can see from the cosine part of it that a is 0. And from the sine part of it, I can see that b is negative 192 over 16. Because this crap needs to be 1.
Which is 12, by the way.
Which is negative 12?
Negative 12, yeah.
You know you're on the right track when it turns out to be an even number, right? Okay, so what that means in the end here is that I know that y is my homogeneous thing. So C1 cosine 8t plus C2 sine 8t. And then plus my particular solution, so that's going to be minus 12 sine 8t. No, that's not right. What did I lose? So I found b was negative 12, right? So that was here? Wait, b was negative 12?
Yeah.
Wait, what the hell? That's real weird. I was expecting it to be A. You guys see that?
Did the all switcheroo.
Yeah, that's real weird. Okay, so it's not sine of 8t here. It was A was on sine and B was on cosine, but there were t's on each of them, right? So this is minus 12 t cosine 8t. I'm a little bit surprised that it's the t cosine term that survived there. That feels real weird. All right, now what do I do with this?
We have to find C1 and C2.
Yeah, I had initial conditions. I need to use them. Okay, so way up here, which is released from rest 2 inches below equilibrium. Okay. What does that mean?
Y of 0 equals 2 or -2, I guess, depending on what direction you want to go.
Yep. So we didn't. So, point of fact, they should have told me which direction was which here because they supplied that external force. So they have an axis in mind. I'm assuming it's positive is down, but that's not necessarily the case. So I'm going to assume that's y of 0 is 2. And what does released from rest mean?
Oh, this velocity term is 0 initially.
Yep. So they told me my initial conditions were essentially y of 0 is 2 and y prime at 0 is 0. Okay, so I'm going to I need to plug those in. So if I plug in y of 0, well, on the one hand, that's supposed to be 2. On the other hand, that's C1. That piece is 0 and that piece is 0. So C1 is 2. And then y prime at 0. Okay, so this is a little annoying, right? I just need to go through and calculate a derivative again. This last term is going to 0 out in both cases. Is that obvious? One way you could look at it is you could go up and look at the external force. So the external force is supposed to be sine of 8t, right? So at time 0, that external force is 0. So it really is just the homogeneous thing that I'm looking at. That's a method. The other method is you could look at this and say, okay, so in the one case I'm left with a t, and in the other case I've got a sine.
But if you
No, that's not right.
differentiate it, you'll have one term.
Oh, F. They don't both 0 out? Sad face. Seems
You'll
like
still have your sine term. It'll turn into cosine. But that would still make C2 0, right?
I don't know. Let's actually differentiate instead of talking. Right, so we're gonna get. Let's get y prime. So y prime is 8c1 sine with a minus of 8t plus 8c2 cosine 8t. And then here we have a little product rule, so we're going to get minus 12 cosine of 8t. See, I was wrong. That sucks. And then we're going to have a minus 12t sine 8t times 8.
Did you guys really take down as positive again? I was working on the problem on my own for a minute, and I didn't see what you guys were doing.
Of course we took down as positive, Jacob. I don't know what world you live in where you want to use a negative gravitational constant. I already used a positive one.
Grow up.
Always going to do that. It's always going to be annoying for you. Just gives me warmness in my little heart to know that you're annoyed. This is my wife says that this is the part where you get to define your own reality, which is one of the things she thinks is entertaining about math. Is sometimes you get to do this. So there you go. Make down positive. Be your own reality. All right. When you plug 0 in here, let's see. We get that's a 0 term. I get 8c2. I get a minus 12 for some reason, and that thing's 0. So it feels like I get C2 is what?
3/2.
3/2. And so I think all told here, I have, oh, that's nice. We hit the end of the line. Y is 2 cosine 8t plus 3/2 sine 8t minus 12t cosine 8t. And the units on this are in inches.
The answer in the book is in feet. Got to remember that.
Yeah, and the answer in the back of the book is probably in feet because they didn't know this 384 number that you guys knew. So if you watch, like if there's videos of me doing problems in this section, they're all also in feet because I didn't know this 384 number until today. Because I can't be bothered to multiply 32 by 12, I guess. So they're all in feet because I know 32 is the gravitational constant for feet. It doesn't matter at all, except that if you try to use the model, you need to know what the input value should be in, right?
Mm-hmm. Can I just say, it is incredible that you used that completely arbitrary BS unit for mass, and it still came out right?
Yeah, the beauty of some of these is that the beauty of some of these is that units really, really matter when they really, really matter, and sometimes they just don't matter at all.
Yeah.
It is really hard to get used to thinking about when the units are going to matter and when they're not going to matter. Yeah, that actually. There's a whole discipline of mathematics called dimensional analysis that deals with this kind of problem.
Mm-hmm.
Any questions on this whole thing? Okay. Roughly, the procedure on all these problems amounts to write down the governing equation, figure out all the, like, as many of the constants as you can, and then do the same thing you've been doing, but now the numbers are way worse. And then the procedure that we've been doing, right, is solve the homogeneous version and then use some technique for the right-hand side. In these, method of undetermined coefficients is a good idea. What's the other technique you could use here?
We use variation of parameters.
Yeah, you could definitely use variation of parameters here. That would make this thing from a like 1.5-page problem into a like 3-page problem. So if you recognize the right-hand side, don't use variation of parameters. If you don't recognize the right-hand side, like if that external force isn't a polynomial, an exponential, or a sine or cosine, then you're going to have to use variation of parameters, and boy, is that going to be rough. You guys with me on that? Variation of parameters is a really slick technique. It's really cool because it almost always works, but man, can it be a bear in terms of space. All right. Otherwise, I hope this color coding scheme kind of made some sense. The moral of the story is write down in big ass bold letters which units you're in.